There are key antigens known as DAMPs, DAMPs, which is damage-associated molecular patterns, and MAMPs, which are microbial-associated molecular patterns. In this video, I'm going to take you through some key mechanisms involved in the pathophysiology of chronic fatigue syndrome. Firstly, the stress and the neuroinflammatory response. 2, alterations in dopamine metabolism in the context of neuroinflammation. And 3, the neuroendocrine response involving the HPA axis. So firstly, let's look at the impact of stress on the brain. Now we know that stress can mount an inflammatory response, which initially begins in the periphery through the release of immune cells from the bone marrow, for example, monocytes. Now when there's peripheral inflammation, there's of course some tissue damage. There are key antigens known as DAMPs, DAMPs, which is damage-associated molecular patterns, and MAMPs, which are microbial-associated molecular patterns. Now, what these antigens do is they bind to the toll-like receptors. These are key receptors on immune cells. When they bind to these receptors, as we can see in this particular inset, they will activate a cascade. Now, this cascade will often result in the release of a number of cytokines. So these are T-cell mediated release of cytokines, which of course cause tissue damage. But the T cell and the interaction with the B cell can also result in the activation of autoimmunity through the humoral pathway, which means the production of antibodies. Now, these antibodies further go ahead and result in tissue damage. So we know there is a link from the periphery to the brain. And this pathway, of course, involves both the cellular route and the humoral route, which is the antibody-mediated activation of brain tissue. Now, we know that the key immune cells in the brain are microglia. Usually, they're in the resting state. But once the immune system is activated in the brain, they become activated themselves. We know that these activated microglia will further mount an immune response and therefore set up a vicious cycle. So the presence of DAMPs and MAMPs that we talked about and their engagement with the TLR can result in a vicious cycle of increasing reactive oxygen species, ROS as we call it, or reactive nitrosative species, and pro-inflammatory cytokines. And this involves both the periphery and also the brain. So this is, in summary, how stress and neuroinflammation come together.